Alright, hello and welcome back. It's your boy Hank Hackerson at Hank Hacks Hackers, your favorite network and system attacker. And we are now going into the Windows Forensics room inside of the Digital Forensics and Incident Response module of the SOC Level 1 pathway in tryhackme. And this is where it gets super freaking fun because we are doing things that the FBI do, baby. So we are now going to go into the Windows Forensics rooms, which is also another free room inside of tryhackme, and you actually get access to the virtual machine that's in here, so on and so forth. So I invite you to register for that and have some fun with it. There's a link in the description below that'll get you there. So let's jump into the Windows Forensics room. If you're interested in digital forensics or security analyst or pen test or ethical hacker, any of that stuff, I invite you to like, subscribe, and turn on notification bell, and maybe even drop a comment. When you do any of those things, two things happen. Number one, you actually help the channel get a little bit more reach with the YouTube algorithm, so on and so forth, so more people can find us and we can help more people just like you who are trying to become a security analyst or an ethical hacker. But the more important thing is that you actually get notified. When you turn on that notification bell, you actually get notified that the next time a video comes out. And if you're studying to do any of those things, this directly applies to you. So today we're about to learn how to use Windows to do digital forensics, which probably applies to you as an ethical hacker, security analyst, incident responder, so on and so forth. So very, very important. And I think it's a win-win thing for everybody involved. So without further ado, let's now jump into the introduction of the room. All right, computer forensics for Windows. Forensics is an essential field of cybersecurity. It's a part of the wider digital forensics field. And the application of digital and computer forensics are very wide and I would say probably deep, from the legal sphere, where it's used to support and refute a hypothesis in a civil or criminal case, to the private sphere, where it helps internal corporate investigation and incident and intrusion analysis. So it's a pretty big deal. The good example of this would be the criminal case in BTK serial killer. This has gone cold for more than a decade when the killer started taunting the police by sending letters, and the case took a major turn when he sent a floppy disk to a local news station that was later taken into evidence by the police, and the police were able to recover a deleted Word document and use the metadata and some of the other evidence, and they pinpointed and they arrested the guy because he got too cocky. Microsoft Windows is by large the most used desktop operating system right now, so private users and enterprises prefer it, and it's currently holds roughly 80% of the desktop market share. This means that it's important to know how to perform analysis, forensics analysis on Windows. And if you're interested in digital forensics, right? So forensic artifacts. When performing forensic analysis, you will offer here the word artifact. And they are essential pieces of information that provide evidence of human activity. For example, in a crime scene, fingerprints, a broken button off of a shirt, the tools that were used to perform the crime, they're all considered forensic artifacts. All these artifacts are combined to create the story of the crime that was committed and what happened, so on and so forth. In computer forensics, the artifacts could be small footprints of the activity on the computer system. On a Windows system, a person's actions can be traced back quite accurately using computer forensics because of the various artifacts a system creates for given activity, and they often reside in locations that normal users won't typically venture to. So for our purposes, we're going to be analyzing these things to triage activity for an investigation and see what's going on. So is my computer spying on me? Probably, right? So it's like it's keeping track of what you're doing. So in a certain way, yeah, it is. Is all the tracking for malicious purposes, or is there another reason for that? And that's the kind of the purpose for this, right? It's like people are like, yeah, Big Brother is always watching me. That's kind of what they mean, because if you do something shady and you did anything on a digital device, there's evidence unless you know what the hell you're doing and you wipe everything, so on and so forth, which most criminals don't, because they're not hackers. They're just idiot criminals. So that's kind of what it's like. That's what that really means, right? Assuming the same build of Windows is installed on a system, excluding the actions that taken during installation, the out-of-the-box experience is similar for everybody. However, with time, each user personalizes their computer according to their preference, and the preferences include layouts and icons, the bookmarks, name of the user, installing different applications, logging in different accounts, and so on and so forth. So Windows saves these preferences to make your computer more personalized. However, forensic investigators use these things as artifacts to identify what just went on and who you are. So, yeah. While your computer might be spying on you, it's not for explicit reasons of spying. Instead, it's to make it more pleasant to use the computer according to your taste. But the same information is used by forensic investigators, basically saying, don't do anything illegal and keep your freaking nose clean. Stay on the straight and narrow or whatever, and you will not have to worry about any of this blowing back against you. But if you're a criminal, yeah, dude, yeah, it's spying on you. Okay, so question: what is the most used desktop operating system right now? Microsoft Windows. And I know all the Apple people hate hearing that, but Microsoft Windows, as far as management of an organization and a lot of things, it's just way, way better. So yeah, there's that. Let's move into Windows Registry and forensics. All right, the Windows Registry is a collection of databases, basically. And it goes like this. So you have the H key, current user, users, local machine, classes, root, and config. And so it doesn't say it like this. It usually is, HKLM would be H key local machine, right? And you kind of need to be able to decipher that, I guess. The keys and values is a big part of this. So knowing what key you're looking for and what the value inside of that key would be. When you open regedit, which is the registry edit executable, the folders you see are registry keys, and the values that are stored inside the keys are called values, right? So it's the data that's stored inside each of the keys. And the Hive is a group of keys. So a registry Hive is a group of keys with all of its subkeys and the values that are stored inside that place. So you can view it by running regedit, and then this is what it looks like. And then this piece right here, that's a registry key. That's a registry key. And inside this registry key, the default is the value, whatever that is, right? So we can see the root keys in the left pane that shows the included registry keys, and the values in them are in the right pane. So we have some folders with their predefined keys. So the H key current user is the root of configuration for the user who's currently logged on. Their folders, screen colors, control panel settings, everything is stored here. This information is associated with the user's profile, and sometimes it's abbreviated as HKCU. Then there's H key users, and it has all the activities load that are associated to all the user profiles. It's a subkey of H key users. So a current user is a subkey of H key users, and H key users is sometimes abbreviated as HKU. And so we have the local machine, which can be HKLM, and then you have the classes root, which is a subkey of the local machine software key, and this information is stored that makes the current program when you open Windows Explorer. And so the software classes contains default settings that apply to all the local computer. The key settings has settings that override the default settings and apply only to the interactive user. And then the class's root key provides a view of the registry that merges the information from these two sources. It also provides the merged view for programs that are designed for earlier version of Windows, and change the settings for interactive user. The change must be done under H key current user software classes instead of H key classes root. To change the default settings, you can go to local machine software classes. If you write keys to a key under classes root, the system stores the information under local machine software classes. If you write values to the class's root, the key already exists under software classes for the current user. The system will store the information there instead of the local machine software classes. And then you have the current configuration that contains information about hardware profiles that are used by the computer at startup. And so what is the term for HK? So it's HKLM is local machine. All right, accessing registry Hives offline. So if you want to access a live system, you'll be able to access the registry using regedit, and you'll be greeted with all the standard root keys, yada, yada, yada. If you have access to a disk image, you must know where the registry Hives are located. The majority of them are inside the Windows System32 configuration directory and are the default SAM security software and system. And these things, as you can see, so it's mounted on different locations, but they're inside this directory. And that's kind of what it looks like. So the default is on the user's default, SAM is on the local machine SAM, and security, local machine security, local machine software, local machine system. Containing user information would be in users and then the username. And so NT user data, that's what is mounted under the current user when a user logs in, and the user class data mounted on the user software classes. And the user class data Hive is located in the username. So users, username, app data, so on and so forth. But this is inside the file explorer. It's typically not the actual key that you would look for inside the registry editor. And this is kind of an example of what it looks like and all the things that actually exist underneath that specific thing, right? So this is basically all of the apps that are inside of the machine that somebody has, including all the things that they probably download and install as well. And so the net user data is located in this directory. And then this is all the stuff that would be associated with that user, including their desktop and documents and downloads folders and everything else that would be inside it. I also have a little thing called PyCharm projects, and that's usually what happens when you install PyCharm, and it just automatically creates a folder for you for PyCharm projects. And PyCharm is a Python editor, as the name can kind of hint at. So these are hidden files, so this is kind of important to think about. And the amcache Hive is another very important Hive, and it's located inside of this directory, so under programs amcache. And Windows creates this to save information on programs that were recently run on the system. So transaction logs and backups. So we have obviously transaction logs, which can be a journal of the change log of the registry Hive. They use transaction logs to write data to registry Hives. This means that the transaction logs can often have the latest changes in the registry that haven't made their way to the registry Hives themselves. And the transaction log for each Hive is stored in a log file in the same directory as the Hive itself. And it has the same name as the registry Hive, but the extension is a log. For example, the log for SAM Hive will be located inside the config file under SAM log. Sometimes there can be multiple transaction logs. In that case, they will have log 1, log 2, etc. And it's good to look at transaction logs as well when performing registry forensics. So backups are the opposite of transaction logs. There are the backups of the registry Hives located in the config directory, and these Hives are copied to the Windows system reg backup, registry backup directory every 10 days. It might be an excellent place to look for if you want to suspect, or if you suspect that some keys might not have been deleted or modified recently. So what is the path for the 5 main registry Hives, which is default SAM, yada, yada, yada. So if we go back up here, it's at the very, very top. And so all of these things, this is the path for the main registry files, and they're right here. So we're going to copy this, and we're going to take that all the way down here, and that's going to be ours. And so what is the path for the amcache Hive, which is this wonderful thing right here? And this is the recent registry changes. So very good. And we have that. And there we go. Or I'm sorry, not registry changes, my bad. That is the recent programs that were run on the system. So that's important to know. That's actually a very good little history type of file. Okay, so now moving on to data acquisition. When performing forensics, we will either encounter a live system or an image taken of the system. For the sake of accuracy, it's recommended practice to image the system or make a copy of the required data, then perform forensics on it. So you rarely want to do anything on a live system unless you want to retrieve what is called the RAM data, right? So that's what we covered in the intro to forensics, where we looked at the volatility. So the disk image is less volatile, therefore less important than the RAM memory that is on the machine. So the RAM resets whenever the system turns off. And so if it's a live system, you kind of want to be able to get as much of that RAM information as possible. But if it's a live system, the key here is to use a write blocker and get an image of that system. So at least you can get access to all of that data and transfer it over. Data acquisition, below we discover ways to acquire registry data. And so let's look at that. We have the registry editor that we just looked at. And the way to acquire a copy of this is to perform, or the correct method is to acquire a copy and perform analysis on the copy. And then when we go to the registry Hives for this location, we cannot, because it's a restricted file. So we now use CAPE. It's a live data acquisition and analysis tool, which can be used to acquire registry data. It is primarily a command line tool, but has a GUI. And this is what the GUI looks like. We've selected all the settings to extract the registry in this screenshot. So we'll learn more about this when we actually use the CAPE room. And so if we can kind of zoom in a little bit on this. So the target source is the C directory, which is basically the root directory of a Windows system. So C dot or colon forward slash backslash, excuse me, is everything. And the destination is going to be where we want it to be saved to. And then you have all the registry Hives and everything else that you want to download as your information, your data that you're downloading. So that's what CAPE does. And we have Autopsy, which gives you the option to acquire data from both live systems and a disk image. After adding your data source, navigate to the location of the files that you want to extract, and then right-click to extract the files option, and it will look similar to what we see right here. So right here, this is being done inside of Autopsy. So this is actually inside of the Autopsy app, and you have the connection right here, and it just shows you that, you know, I want to extract these specific files. So it lets you do that. And how do I zoom back out of this? There we go. All right, and the next one is the FTK imager. It's similar to Autopsy, allows you to extract files from a disk or image or a live system. Below we can see the screenshot. So this is kind of what this one looks like. So similar, it just opens it up, and then it has an export files button that I think is it's one of these buttons at the top right here. And then that is it. FTK stands for Forensic Toolkit, and that's also a really big one that's referred a lot. They actually talk about that inside of the preparations for the CompTIA CYSA Plus exam. So you should be familiar with what FTK stands for. And of course, we have the FTK imager for the Obtain Protected Files option. And it's available only for live systems and is highlighted in this screenshot. So this is when you're connected to a live system, not an image of a system. And you want to use the specific folder right here. And so if they press that plus button, then it opens up the hierarchy of this, and you can see everything that's inside the system. So you just click on that, and then you do extract, excuse me. There we go. And so now we are done with the potential data acquisition tools that we can be using. So we're going to go explore the Windows registry some more. Once we have extracted our registry Hives, we need a tool to be able to view these. as we would in a registry editor. Since the registry editor only works in a live system and can't load exported hives, we can use the registry viewer, and this is the access data registry viewer, which is similar to the Windows registry editor. And it says there's a couple of limitations, so it only loads one hive at a time, and it can't the transaction logs into account. So those are they're kind of big limitations. Maybe not the one that it loads one hive at the time, but the transaction logs, I would presume, is pretty important. Then we have the Zimmerman Registry Explorer, and this is what the screenshot looks like. It can load multiple hives and add data from transaction logs. So I feel like this one is kind of the better one. It might be non-open source. I can't remember if it was open source or not. But if it's paid, I mean, the FBI will pay for this gladly, right? Or whatever organization you're working with, they'll pay for this kind of stuff. So you don't have to pay for it out of pocket. But it's very important because you want the transaction logs, dude, to make a more cleaner hive with more up-to-date data. They also have a bookmark option containing forensically important registry keys. I think it's pre-populated for you. It's pre-filled, so you kind of know what to look for that usually forensic investigators would look into, which is, again, very, very helpful. So if we have to use Registry Explorer versus the Registry Viewer, I would probably use the Explorer, and that's just me. Then you have RegRipper. Or RegRipper, but it's kind of harder to say. So RegRipper is a utility that takes a registry hive as inputs and outputs a report that extracts the data from some of the forensically important keys and values. So it outputs it in a text file, and it shows everything in a sequential order. And I really don't like looking at text files because the formatting sucks and you have to be really, really good at searching through them. So if you're really, really good at searching, then that would probably be the route that you would want to take. It says one of the shortcomings is that it does not take the transaction logs into account. And that's why we go back to Registry Explorer. So that's just, my opinion. That I feel like that's just the tool that we should use. I don't even know why they even talk about anything else, but they want you to have multiple tools just in case you don't have access to Registry Explorer. So there's that. Now let's move on to the system information and system accounts. So we have learned how to read registry data. Let's look at the registry to perform the forensic analysis. And so the OS version, if we only have triage data to perform forensics, we can determine the OS version from which the data was pulled through the registry. And to find the OS version, we'll just go to Software, Microsoft Windows, Windows NT, and the current version. And so it'll give us all the information about the current OS, including the specific, this is just basically the current version 6.3. It'll say the product name, the release ID, so on and so forth. So it is important to know these kinds of things because you can pull a lot of data about what was not patched with that version or what the particular vulnerabilities are with that version, which is, I guess, saying the same thing. The current control set. So the Hives containing machine configuration data used for controlling systems are called control sets. Commonly, we'll see two of them, control set 01 or 001, 002, and it's in the system hive on a machine. In most cases, the 001 will point to the control set that the machine booted with, and 002 will be the last known good configuration. And this is system, control set 1, and control set 2. Windows creates a volatile control set when the machine is live called the current control set, and it's HK local machine system current control set for getting the most accurate system information, and this is the hive that we're going to refer to. We can find out which control set is being used by looking at the registry value under system, select current, and similarly the last known good configuration can be found using the following registry value, system select last known good. And this is kind of how it looks like. inside Registry Explorer. See, they're using Registry Explorer. They wouldn't use any of the other stuff because it has the freaking transaction logs, man. So take a look at answer to question number 2. So this is going to give us question number 2 here. We'll do it later. Okay, so this is what we have. The current default failed, unassociated deleted values, THM, forensics desktop, user class, data, clean, yada, yada, yada. It's vital to establish this information before moving forward with the analysis. As we will see, many artifacts will be collected from control sets. Okay, good to know. The computer name, so system, current control set, control, computer name, will bring us the computer name, which is going to be the actual name of the host that we're on. And then time zone information, current control set, control, time zone information, very important. Network interfaces and past networks, current control set, services, TCP IP, parameters, and interfaces. And this is what we're looking at over here. And it has 5 interfaces in this particular case. And it gives us the information about this. For example, the DHCP name server and the default gateway, so on and so forth. Each interface is represented with a unique identifier, the GUID, which does not show us in this screenshot, which contains values related to the interface's TCP IP configuration. This key will provide the information like IP addresses, DHCP IP, subnet mask, DNS servers, so on and so forth. It's significant because it helps you make sure that you are performing forensics on the machine that you are supposed to be performing on. And the past networks a given machine was connected to, can be found in the following locations. So software, Microsoft, Windows NT, current version, network list, signatures, unmanaged or managed. And then this is what that looks like. These are the past networks. And then you have the auto start programs, which are the auto runs, which are also very important because a lot of times in the previous pen testing videos, we've actually taken advantage of the auto run programs that were set up because sometimes a developer will create something and they will delete the executable or whatever the script was, but they won't delete the line item inside the auto runs. And in Linux, I think it's called cron jobs or cron tabs, something like that. And these are things that, again, you can take advantage of, or at the very least go look at, because they may have deleted the executable, but they may have left the run and the auto run line item inside of the auto run auto start programs. So these are the locations that include information about programs or commands that are supposed to run when a user logs on. For example, a backdoor, right? Like a command and control executable, or a bug, or a rat. Any of these things can be an auto run function that as soon as a user logs on, then the backdoor opens and the information starts being connected to the C2 server. The registry key contains about services, which is this thing, current control set, and it has a value of the start key in the screenshot below, which is start right here, which is 2, I guess. Is that what we're looking for? The start key, or the bind FLT, that might be it. And then moving on to the next one, which is the SAM, Hive, and user information. This is a big one. It's like a very important file. It has a lot of information about the current users and sometimes even their password hashes. So that's very, very important. You can dump this using Mimikatz or just a lot of tools that hash dump, I think, even does it. So it's very, very sensitive file. The SAM Hive is a very sensitive hive. And account information, login information, group information, all that stuff. So this is what the screenshot looks like for question number 6. And now we have a bunch of things. So it says, what is the current build number of the machine whose data is being investigated? So we're going to go back up to the section where they told us to go to question number 1. And so right here, so we're looking for the current build number here. And so the build revision number is 1 right here. Let's see what else we got. Current build is 19044. So that's what that is. So we're going to go here and we're going to do 19044, or my keyboard needs to reconnect. There we go. Which control set contains the last known good configuration? So that's going to be for the one for question number 2. The control set that has the last known good configuration is the last known good is, what is it? Last known good. I think that's what it is, right? Last known good, select. I believe that's the answer. So let's see if that's what we're supposed to be doing. Oh, 1. So it was 1 actually. So now we are going to go to the next question, which is the computer name of the computer. And that was question number 3, and we saw it already. It was THM something. The computer name is THM 4 and 6 for Nancy 6. So THM dash 4 and 6. And what is the value of the time zone key name? The value of the time zone key name, which is going to be for question number 4 right here. The time zone key name would be time zone information. And let's see if there's a value down here. Time zone key name actually is going to be Pakistan Standard Time. So they were hacking us from Pakistan, these motherfuckers. There we go. So we got that. And I know actually we have viewers from Pakistan on this channel. I was looking at the analytics the other day. So shout out Pakistan. You guys have apparently some really good hackers out there. What is the DHCP IP address? DHCP, and this is what, question number 5? So we're going to go up to question number 5. Let's see if we can find that right here. So the DHCP IP address is right over here. So 192.168.158. 192.168.158. And the RID of the guest user account, which is the very last question here. And we're going to look at the guest user account, which is right here. And their RID is 501. And just like that, we have looked at some of our registry key values and answered some key questions for this particular room. So now we're going to move into the usage or knowledge of files and folders. All right, recent files. The Windows maintains a list of recently opened files, and as we've seen using Windows Explorer, it shows a list of recently used files. This information is stored in the NT-user Hive and can be found on the following location. So NT-user data, software, Microsoft Windows, current version, Explorer, and recent docs. That's what that would look like. And usually this actually shows up when you do the File Explorer and you open it up. It shows like recent. There's an item called recent, and you just click on that and it'll show you all the recent things that were accessed, but this is the actual registry key for it. So, or the Hive specifically for it. And so this is where all the recent docs have been. The Registry Explorer allows us to sort the data contained in a registry key quickly. For example, recent document tab arranges the most recently used file at the top of the list. The Registry Explorer also arranges them so that the most recently used file is shown at the top of the list and the older ones later. So we have the, what is the Registry Explorer, and then recent documents are aligned. So another interesting piece of information is that there are different keys with the file extensions such as PDF, JPEG, docs, and these provide us with the information about the last used files of a specific extension. If we're looking specifically for the last used PDF, we can look at the stuff that is under .pdf. Office recent files, so it would be under Microsoft Office version, so Microsoft Office 15.0, and then Word would bring us all of the recent Word files. Then we have the, let's see, we have the, what is this? So the 15 right here refers to Office 2013, and then there's different releases and their version numbers through that link. And so we might have to refer to this link a little bit later, so I'm just going to open this up real quick. And then it says from starting from Office 365, now Windows ties the location to the user's live ID. So in a scenario, the recent files can be found at the following location, which would be Microsoft Office, and then the version number, user MRU, live ID number, and then file MRU. Shell bags. When a user opens a folder, it opens a specific layout. Users can change this layout according to their preference. These layouts can be different for different folders. This information about the Windows shell is stored and can identify the most recently used files and folders. Since this setting is different for each user, it is located in the user Hives, and we can look at it here. So user class, and then the net user, and then you have local settings, software, Microsoft, so on and so forth, then software, Microsoft, Windows, shell, so on and so forth. So Registry Explorer doesn't give us much information about shellbags. However, another tool is called Shellbag Explorer, and it shows us the information in an easy to use format, and we just have to point to the Hive that we have extracted, and it parses the data and shows the results. An example is this, and we can use it to answer question number 2. Open, save, and last visited dialog MRUs can be found at these registries. And it might be noticed that once we open, save a file at a specific location, Windows remembers that. This implies that we can find our recently used files if we get our hands on this information. This is what it looks like on Registry Explorer, and we can use this to answer the next set of questions. And Windows Explorer address search bars. Another way is looking at the paths type in the Explorer address bar or searches performed during the following. So these are where that would be stored. So anti-user, Windows current version, Explorer, typed paths, and word wheel query. So this is all stored. So everything that you do is actually being stored. So let us go and answer some of these questions. So when was Easy Tools opened? And we need the full thing. So I wonder if we can get registry last one files. Answer question 1 by looking at the above screenshot. So Easy Tools needs to be, I need the full thing, and I can't copy paste it, so I gotta try to remember it. So Easy Tools right here. It was opened on December 1st, 2021 at 130034. So it's 2021, right? That's how we want it. Yeah, 2021. December 1st and 130034. Yeah, okay, great. At what time was my computer last interacted with? And that would be for question number 2, which is up here somewhere. Where's question number 2? Right here. At what time was my computer interacted with? And 13:06:47. So I need the date too. So where was it? My computer, 12/1/2021. Okay, so 13:06:47. So 2021, 12:01. What am I doing? 12:01, 13:06:47. Good Lord. Okay, what is the absolute path of the file that was opened using Notepad? And that's going to be for 3 and 4 right here. That's the absolute path. So I have to zoom out and try to type this, see what I can see. So it's, so I don't need the My Computer part. I just need the C, and then Program, Files, Amazon, EC2 config service settings. And when was that file opened? It was opened on December 1st, 2020. Oh, no, I'm sorry. 11:30. So that is November 30th. So 2021, 11:30. And then we have the 10:56:19. And just like that, we answered our questions for this. So now we can go to evidence of execution. Execution evidence. Evidence of execution has to do with the user assist first. So Windows keeps a track of applications launched by the user and using it and using Windows Explorer for statistical purposes in the user resist registry keys. These keys contain information about the programs launched, the time of their launch, and other details. However, programs that run using the command line can be found in user assist keys. It's present under the net user Hive, mapped to each user's GUID. And so we're going to use this to answer question number 1. The shim cache is a mechanism used to keep track of application compatibility with the OS and tracks all applications launched on the machine. Its main purpose is to ensure backup compatibility of applications. It is also called application compatibility cache, so app compat cache, and it's located in this Hive. Shim cache stores file names, size, last modified time of the executable, and the Registry Explorer doesn't parse shim cache data in human readable format, so we go to something called the app compat cache parser, which is part of Eric Zimmerman's tools, and it takes the system Hive as input, parses the data, and outputs a CSV file that looks like this, which is super human readable. And we can use the following command, to run the app compat parser utility if you haven't installed, obviously. The output can be viewed using Easy Viewer. Then we have the am cache, the artifact related to the shim cache. This performs a similar function and stores additional data related to program execution. This includes execution path, installation, execution and delete times, and the SHA-1 hashes of the programs. This Hive is located in the file system at this location, and the information about the last executed programs can be found in this Hive under the GUID for the volume. And this is how it parses the am cache. So this is kind of a screenshot right here. And then we have the BAM and DAM. So background activity monitor is BAM, and it keeps tabs on the background applications, and desktop activity moderator is part of the Windows that optimizes the power consumption of the device. So both of these are part of the modern standby system in Microsoft Windows. The locations right here store information about BAM DAM, and it contains information about last run programs, their full paths, and last execution time. And you can see they are BAM DAM specific. And then there's the SID, which has to do with the security ID of the user. So question 1 says, how many times was the File Explorer launched? So we're going to go up here and look at this and kind of open this up, and we're looking for File Explorer to see how many times it was launched. So let me kind of zoom in a little bit more here. And so there we go. File Explorer was launched 26 times. So let's go and get that. And what is another name for shim cache? And that thing is app compat cache. And we're going to copy this and go down here and do that. And that's the answer for that. And which of the artifacts also saves the SHA-1 hashes of the executed programs? And it's am cache. And we're going to do that. And finally, which of the artifacts saves the full path of the executed programs? And that would be BAM DAM. BAM DAM. Wham bam, thank you ma'am, bam dam. And voila, just like that, we have finished the evidence of execution. So now moving on to external devices and USB device forensics. This is I think this is going to be a very important one. All right, so device identification. The following locations keeps track of USB keys that are plugged into the system. They store the vendor ID, product ID, and version of the USB device, and they can be used to identify unique devices. So they also store the time that the devices were plugged into the system. So current control set and enum USB store and USB. So that is actually very useful. And everything, as they said, is under the control set, the current control set, or most of them are under the current control set. You have first and last times. Following the registry tracks the first time the device was connected, the last time it was connected, and the last time the device was removed from the system. And so this is where all of that is being stored, which is pretty gnarly. So it's under USB storage, the product version, USB serial number, properties, and then that's the actual probably GID or SID. And then the hashtag signs can be replaced by the following digits. So 0064, first connection time, the 66, last connection time, and 67 is the last removal time. And then we have the device volume name. So software, Microsoft, Windows, portable devices, and devices. And that's the Hive that we will be looking towards. And we can compare the GUID we see here in this particular registry key and compare it with the disk ID we see on keys mentioned in device identification to correlate the names with the unique devices. So take a look at these and answer question number 3. And combining all this information, we create a fair picture of USB devices that were connected. So first we need to see the serial number of the device from Kingston. And the serial number of the device from Kingston is this one right here. And it ends in, how am I supposed to, am I just supposed to type this up? That's insane. Okay. I guess I'm going to type that up first. And then we're going to paste it. That's crazy though. How am I supposed to freaking type this up? I wonder if it's like inside the machine that we're supposed to be looking at. Whatever. All right, I'll just bite the bullet and I'll just type it up manually. Who cares? Let's do that. I'm going to open up a text editor and I'm going to zoom in on this and I'm just going to access it in a different text editor. Oh, dang. Okay. Okay, so let's hope that I type this correctly inside my little text editor and it actually comes through right. Okay, good. Okay, thank God. All right, so what is the name of this device? And the name of the device is going to be the device name Kingston Data Traveler 2.0. So Kingston Data Traveler 2.0 USB device. Okay, so Kingston Data Traveler 2.0 USB device. Cool. And what is the friendly name of the device from the manufacturer Kingston? And so the friendly name, so we have to look at it based on the GUID that we found. And so 7110, so it's not the serial number, it's the disk ID right here. So E2519221F, because both of them end with 710. So it's the one that starts with E, because the other one starts with an F. So fairly easy enough. And so it's the one that starts with E, which is right here, and it says USB, and it's the only 3-letter answer. So there is that. We just got it. So external devices and USB device forensics. And now we get to jump into our hands-on challenge. So let's launch this machine and let's do the hands-on challenge. All right, so while that loads up, let's read through the setup here. So use the following credentials if you want to do RDP into this thing. Once we log in, we see 2 folders. We have triage and easy tools. The triage folder contains triage collection collected through CAPE, which is the same directory structure as the parent, and this is where the artifacts are going to be. And easy tools contains the tools that we got from Zimmerman, the man. So we're going to find Registry Explorer, Easy Viewer, and App Compact Cache Parser in that folder. The challenge is this. One of the desktops in the research lab at Organization X is suspected to have been accessed by someone unauthorized. Although they generally have only one user account per desktop, there were multiple user accounts observed on this system. It is also suspected that the system was connected to some network drive and a USB device was connected to the system. The triage data from the system was collected and placed on the attached VM. And so we gotta try to answer these questions. When loading registry hives in Registry Explorer, it will caution us that the hives are dirty. This is nothing to be afraid of. We just need to remember the little lesson about transaction logs and point the Registry Explorer to the log1 and log2 files in the same file name as the Registry Hive. It'll automatically integrate the transaction logs and create a clean Hive. Once we tell Registry Explorer where to save the clean Hive, we can then use that for the analysis and we won't need to load the dirty Hives anymore. So it'll guide you through this process. And now we are going to actually run through this mofo. So what I am going to do is I'm going to open up the machine in a new tab because it's a Windows machine and typically we want it to just be a little bit easier to access. And especially if we're going to use these devices, it's going to most likely, what is this tab that I opened? This is supported scenarios for installing different versions. Oh, that's not fun. It's okay. And we can close this one. This should be our remote. And there it is. So we got that. And so while that loads, it should be loading, right? So how many user created accounts are present? The hint says check the SAM Hive. Accounts with RID starting with 10XX are user created accounts. What is the username of the account that's never been logged in? Check the account that does not have a last login. What is the password for the user THM4N6? And password hint column. And change log. So format is this, check in evidence of a file folder opening. And then what is the complete path from where the Python 3.82 installer was run, evidence of execution, and then we have the format for the USB drive that we need for the date and time. So we got all our hints. Now it's time to run the exercise. All right, here we go. So we need to probably use our easy tools to launch our Registry Explorer. And let me see where it is. It's inside this thing. And then I have the application for Registry Explorer. So we're going to launch that. And we got to find the information that we need to load, which is going to be inside the CAPE folder. And it's going to be documentation, modules, targets, the change log, gcape, so on and so forth. So targets, let's see what's in here. These are all of the different things right here. Modules, all of our different modules. And we have documentation, and that's just the documentation. So I think everything is either going to be, yeah, so browsers, compound, logs, got it, P2P. And then the modules themselves are where browsing history and a lot of these other things are done. Okay, so the first question is related to the user created accounts on the system, and this is going to be in the SAM Hive. Okay, so this is, I think, going to be the tougher part of this, for me specifically at least, is locating where these things actually are. So it says that for the first question, we need to find the SAM Hive, and that's what the hint gave us. And to try to find the SAM Hive, I had to just keep clicking around to try to find it. And so the SAM Hive is inside. So you open up triage, C, Windows, System32, configuration, and then here's where it is. And then we probably have to connect the log file next to it. So as soon as I do this, it's going to give me some kind of like a dirty message or something. Okay, seems to be fine. So now we can open this up, open that up, and then we're going to go to domains, and we're going to go to accounts and users, and here is what it is. And so what we need to do now is how many users created accounts are present on the system. So if we actually click on users, we get this whole information here. I'm just going to kind of shrink this down a little bit. So this is a little bit easier. And user created accounts is what we're looking for. And right here, let's see if there's any other data in here for us. If I expand this, this might be a little bit easier to see. Okay, very good. So now we have our user created accounts, and it would be these three right here. So THM user, THM user 2 would be our user created accounts. So that would be 3, and that is the ones starting RID with 1000 are the ones that have been created by the user. What is the username of the account that has never been signed in? Check the account that does not have a last login time. And so it's never been signed in, which is last login right here. And that is THM user 2. So let's see if we could copy this value. Might not be able to copy it with right click, so maybe I could do that. Username THM account 2, there we go. And there's that. What is the password hint for the user THM4 and 6? Check this. So this is all still in the same thing. And password hint THM6 is count. So that's the password hint. When was the file changelog txt accessed? And check in the evidence of file folder opening. Okay, so I think now we need a new log file. So we got to open up a new Hive, and it would be in users for this guy right here. And what we need is the which is the log? I think it's nope, not that. App data, probably not that either. And maybe NT user data. So if we go to task 7, it shows us that files that were opened are all under the ntuser.dat. So ntuser data. So that's the one that we are actually going to open. And then now it says, I see, so this dirty Hive detected. Okay, so now we need to connect a log to this. To bypass this and have log replace, click shift when holding logs. Got it. Okay, so we're gonna here do it to replay. Okay, we're gonna begin, and we're gonna use the first log file, and there's that has been replayed. And okay, and we're going to also save it in the this desktop, not desktop, it's going to be in the triage C users THM, and then we're going to do this. We're going to save it exactly here, and has been updated. Do you want to load the updated Hive? Yes. If it fails to load, disable options, recover deleted values. Okay. Do you want to load the dirty Hive? Yes, I guess. Okay, so one of them is dirty. I need the one that is clean. It's the one that I need. I should have not loaded the dirty Hive. That's probably my bad. So this is the one that's clean. So now we have this, and we're going to open this. And so what are we looking for again? We are looking for the when was the file changelog accessed, and check in the evidence of file folder opening. Changelog access. So going back to here, we're looking for, it's actually the very top one, so it's the recent files. So it's going to be under software, Microsoft, Windows, current version, Explorer, recent docs. So software, we got Microsoft, we got Windows, current version, and what was it? Explorer and recent docs. Gonna go down to Explorer and then recent docs. Okay, so we click on that and it opens that up for us over here. And now we are looking for something that was used with, they said the TXT, right? So changelog TXT right here. Very good. So it's the extension. This also helps a lot. So it actually has the TXT extension. So changelog TXT and changelog such and such, and it's been opened on this date. So if I do Control C, that should copy it, and then come here and go back down here and just do that, and then delete the first part, and that should be it. Great. Okay, great. So what is the complete path from where the Python installer was run? Evidence of execution artifacts. So we're going to go up here and evidence of execution, and it's going to be inside of any of these things. So let's say we're going to go to the first one, which is also NT user data, software, Microsoft Windows, current version, Explorer, user assist, GUID, and then count. So Explorer, and it's going to be under user assist, and the GUID for my current user, which I don't know actually the user ID for my current user. So it's probably something that I should have taken a note of. But it's actually up here. So I can go up here. This is the previous one that we ran. We're going to go to root and our users and our THM user. This is GUID here. His GUID is not here. So I have a user ID. I don't have a GUID. What about values? Nothing. So I have his user ID, but I don't have his GUID. And I got to find that. So let's see. Okay, unfortunately for this one, since I don't know the GUID, I'm going to have to just click through all of these and try to find the one that has some values for us to analyze. And it seems to be, okay, here we go. We found something here, and now we are looking for something that may potentially have Python in it. So let's see, there we go. So setup right here, Python 3.2 extension. And what's the question? The question is asking, what is the complete path where the installer was run? And it could be this. I don't see any other Python. So that could be it. So I'm going to copy this one. And we're going to paste that and delete this section. All right, cool. There you go. And so finally, when was the USB device with the friendly name USB last connected? And that's going to be right here. And that's going to be in system current control enumeration. So that's the one that we have to load. So we're going to kind of shrink this down. And I guess I could delete the remove Hive. Yeah, I'm going to remove the dirty Hive. Very good. So we have the clean Hive. And so we need to open now the system current control. So C, it's going to be under Windows, I believe. System 32. Nope. So let me, I have to find where this is. So system current control set enumeration, system current control, software, devices. So it could be any of these. So we were actually on the right path. It's going to be in the config, and then in here there should be something called system. And I'm going to select both of them so it has the log file associated. And so it says, do you want to replay the transaction against this Hive? Yes, I do. That's all good. We're going to collect that. I did. What the hell? Like, why would you want me to redo it if I just double click both of those things? That's fine. We're going to collect a updated Hive. It has to actually be under desktop, triage, C, and Windows, system 32 configuration, and this should be it. And it's going to be system clean. So we're going to do that. Do you want to load the updated Hive? Yes. And do you want to load the dirty Hive? And we're going to say no on that one. So we only have one Hive. Excellent. So root, and it's going to be under, what is it? System current control set or software. So system current control set enum USB. So it's under software, Microsoft, CTF, and what do we have here? Assembles, Microsoft. Where is it? So software, Microsoft, Windows portable devices. I see. So software, Microsoft, Windows portable devices. Okay, this one is a little bit challenging. I actually I think I may have spent 10 minutes just to try to locate this thing, which is the very last thing. And trying to find it by the friendly name location didn't work because the friendly name location is this location. And then when I went to this location, so when I went software Microsoft, there is nothing for Windows portable devices. And so if we look at it right here real quick, you know, we have root, and then this is under all of this is under the control set, and then close that out, and we just go all the way down to software. And if we open up software, there's Microsoft. There is no anything other than the one that we're actually supposed to be looking for, which is what is it? Where was it? Let me go back up. Right here, Windows portable devices and devices. So this doesn't exist for Microsoft. This was the only thing that's under Microsoft, which is CTF. And you open that up and it gives you all of these things, which none of these things are actually relevant to what we're looking for. So the only other place that I could find it was the one where it said first and last time. So we go to System, Control Set, Enumeration, USB Storage, so on and so forth. So this is where we ended up at over here, which is USB Storage. And then under this, there's only 2 USBs and the Kingston USB device, and then USB external USB device. And they both have a last connected. So I'm just gonna try one of these two and see which one actually works, and hopefully this ends up being the date, because if it's not, I am stumped and I will have to pull up some information. Oh, there you go. Okay, great. Great. I wasn't able to locate it by its friendly name, so that's the thing, but I ended up going down the other path, which was this kind of a little bit of a longer path. So we went to Control Set, Enumeration for enum, and then came all the way down to USB Store, and then just clicked on that, and it gives you that information right up top from the top. So that is it for our hands-on challenge. And that one was actually kind of challenging. So it just took a lot of time to find the hives, the appropriate hives, and then from there to actually go down the hierarchy of the hives to try to find the information that we needed to look for. But thankfully we had certain things like this where it kind of shows you where general things are supposed to be. So evidence of execution and so on and so forth. These things actually do help to try to find out which hive you're supposed to look for and where that would end up being. That being said, let's jump into the conclusion and wrap this room up. All right, so here we go. That was the conclusion. And we have this wonderful freaking cheat sheet that would have actually been very helpful if I would have looked at this. Probably I should have looked at this in advance, because it gives us all of these things that we wanted and we were supposed to be searching for. So that's pretty useful. I'm definitely going to download that, and this is available for you. And this is a free room, by the way, which means that if you go into this free room, you can also download this task file and have this stored for future reference. And with that, we have now wrapped the room for Windows Forensics 1. And then the next one is going to be Windows Forensics 2. And then from there, we're just going to go further and further down the forensic rabbit hole. All right, so if this was useful for you, and hopefully you got some value from it and learned some good things, please go ahead and like, subscribe, and turn on the notification bell, and even drop a comment. When you do any of those things, it helps us in a few different ways. Number one, it actually helps the YouTube algorithm find the channel so that we can find more people like you who are interested in cybersecurity analysis and forensics and ethical hacking, pen testing, all that good stuff. So it helps us actually build the channel up and build a community up. But more importantly, you actually get notified the next time a video comes out when you turn on that notification bell. And if you're studying for digital forensic, incident response, or ethical hacker, cybersecurity analyst, all that good stuff, you actually will be notified the next time a video comes out, which would be useful for you. So it ends up being a win-win situation. This is your boy Hank Hackerson at Hank Hacks Hackers, your favorite network and system attacker. And this was the Windows Forensics 1 room. If no one else loves you, Hank loves you. Peace, love, and chicken grease. And I will see you in the next room. Later.